Hello guys and welcome to another one. So here we'll be looking at calculating using stoichiometry, and then we'll also be finding our order of crystallization. Okay, let's get into it. So here they say in a reaction 10.6 grams of sodium carbonate reacts completely with excess hydrochloric acid. Then they say calculate the molar mass of sodium carbonate. How does sodium carbonate look? This is the formula for sodium carbonate. It is NaCO3, but it's actually Na2CO3. Yeah, that's the formula for sodium carbonate. Okay, now they say we must find the molar mass. So if we find the molar mass, this is 6.2.1. If we find the molar mass of sodium carbonate, we'll say how many sodiums do we have? We have 2. So I'm gonna say 2 multiplied by the molar mass of sodium. I get it from my periodic table, and there it is. It is 23. Okay, as you can see it's 23, so I'm just gonna put 23 there, plus how many carbons do I have? 1. On the periodic table I'm gonna have 12, plus how many oxygens do I have? 3, multiplied by the molar mass of oxygen, which is 16. What is the answer am I going to get? So the answer I'm getting is 106 grams per mole. Remember that, guys, your answer is supposed to have a unit. Without the unit, the answer will be wrong. Okay, so now we move on to 6.2.2. They say here calculate the initial number of moles of sodium carbonate. So they are saying find the number of moles of sodium carbonate. How do we do that? Well, we'll say N of what? Of sodium carbonate is equal to the mass over molar mass. What is the mass of sodium carbonate? Here it has been given that it's 10.6 grams of sodium carbonate. So I'll say 10.6 divided by the molar mass, which I just found here, and that is 106. What is my answer? The answer I get when I say 10.6 divided by 106 is 0.1 moles. Okay, done. We move on to 6.2.3. What are they saying there? They are saying calculate the mass of carbon dioxide produced during this reaction. Okay, all right, so here, guys, they are saying must find the mass of CO2, but the problem is that we don't really see where CO2 is here, and we are supposed to use ratios. That means we must write balanced equation first to answer this one. So we are told that sodium carbonate reacts with hydrochloric acid, which is HCl, right? It reacts with HCl, and this will produce a product of sodium chloride plus water plus carbon dioxide. Okay, then we have to balance this equation. We see this side we have 2 sodiums, this side we have 1, so I'm gonna put a 2 there. This side we have 2 hydrogens, whereas this side I have 1, so I'm gonna put a 2 there. And now my equation is going to be balanced. After this, now I'm just gonna use ratios. Remember, we are looking for the mass of carbon dioxide, but we don't know the number of moles of carbon dioxide, which we need to find our mass. So we'll find that by using ratios. How did I say we use ratios? Well, we'll say we'll take the number of moles of the substance that we already know about, which is sodium carbonate. Remember, we found its number of moles here, which was 0.1. So we'll say Na2CO3 is to CO2. So we are going to find the number of moles of carbon dioxide using the number of moles of sodium carbonate. All right, and then let's look at the ratios now. The ratios are in a form of coefficients, right? We look at the numbers that are here. At the moment, we see that we have 1 here. We also have 1 here. So that means our ratio in this case is 1:1. If our ratio is 1:1, what does that mean? It means that the number of moles of this substance will be the same as the number of moles of this substance. So what we'll say is, okay, excuse me for that, guys. The number of moles here are what? 0.0 and 0.1. We don't know the ones here, but because the ratio is 1:1, that means the number of moles of carbon dioxide is equal to 0.1. We can find them by also cross multiplying. When I say n times n, I'm gonna get n. 1 times 0.1 will give me 0.1, okay, moles. So those are the number of moles of carbon dioxide. After finding the number of moles of carbon dioxide, what do? I'm now going to just move in this step to here. I'm now going to use the formula N is equal to mass over molar mass. Okay, then for me to find the mass, I know that the number of moles of carbon dioxide is 0.1 is equal to, I don't know, the mass divided by the molar mass. How do I find the molar mass of CO2? For me to find the molar mass of CO2, I'm going to say 12, the molar mass of carbon, plus 2 times the molar mass of oxygen. And what answer am I going to get? The answer I'm getting is 44 grams per mole. So I'm just going to put it here, 44, and then I cross multiply. M times 1 is M is equal to 0.1 times 44 is equal to, the answer I get is 4.4 grams of carbon dioxide. That's the mass of carbon dioxide. Okay, I hope it makes sense, guys. If it doesn't, please make sure that you just scroll back. Okay, let's move on to the next one. The next one is 6.2.24. Okay, so for 6.2.4, they say calculate the mass of sodium chloride produced if 4.87 dm cubed of carbon dioxide was produced at STP. STP means standard temperature and pressure. Okay, and we know here that we are supposed to have a constant volume. Remember, I said when you see STP, you must think the formula N is equal to V over Vm. What are we going to use this formula for? We will use it to find the number of moles of carbon dioxide. Okay, so let's do that. We'll find the number of moles of carbon dioxide. What is the volume for carbon dioxide? It is 4.87. In this case, it's in dm cubed. If it was in cm cubed, you are going to have to convert it. Okay, so we'll say 4.87 divided by our molar volume. Remember, I said this one is a constant, which is 22.4. If you forget it, you can just go to your formula sheet. Let me just scroll down and see where am I gonna. Here it is. Can you see it? Molar volume and it's 22,4 if you forget it. Right, now let's move on by calculating this value. Check how much you get. Okay, the answer we get is going to be 0,2174. Remember I said it's safer to round off the number of moles to 4 decimal places. We'll only round off to 2 at the final stage. Okay, once we are done here, what do we do next? We'll use these number of moles to find the number of moles of sodium chloride. And here is sodium chloride. Can you see it? And what did he say? We are going to write the substance we are looking the information of, and the one we already have the information about, which is carbon dioxide. Remember that this is for carbon dioxide. So we'll say NaCl is to CO2. Write them as ratios. Then we look at their coefficients. We can see NaCl has a coefficient of 2, whilst carbon dioxide has 1. So the ratio here is 2 is to 1. And then what do we know about the sodium chlorine and its number of moles? Nothing. We don't have them. But we know the number of moles of carbon dioxide because we just found them. Here they are. So we'll put them here, 0,2174. Then from here we look for the number of moles of sodium chloride, and they are going to be, I'm just gonna say, when I see this N on the side of NaCl, then I know that I'm looking for the number of moles of sodium chloride, aka NaCl. Okay, so these number of moles are for that. Okay, now let's find them. When I say n times 1, I get n. Then I'll say 2 times 0,2174. What do I get? Okay, the answer I get is 0,4348 moles. Once I have this, guys, what do I do now? I'm gonna find my mass. Remember, that's what I'm looking for. They said here I must calculate the mass of sodium chloride, and this is how I'm going to do it. Let me just erase here. Remember, if you need this information, you can just scroll back on the video. You should find the information. Okay, everything's gone. Let's proceed. So I'm moving from this side to this side now. I have found the number of moles of sodium chloride, so now I'm going to find its mass. But let's start by finding the molar mass of sodium chloride. The molar mass of sodium chloride is going to be 23 plus 35,5 is equal to, let's check. The molar mass of sodium chloride is going to be 58,5 grams per mole. Once I have this, I'm gonna go to my formula. N is equal to mass over molar mass, and then I substitute. What is my number of moles for sodium chloride? It's 0,4348 is equal to the mass is what I'm looking for, divided by the molar mass, which I just found, and it's 58,5. From here we do cross multiplication. M times 1 is M, and what is 58,5 times 0,4348? The answer I'm getting is 25,44 grams. This is the mass of sodium chloride. Okay, that's how you answer this question. For this one of water of crystallization, guys, can you just do it on your own and send me the answers in the comments section? Okay, I hope you enjoyed the video. If you didn't understand, likewise, simply scroll back. And guys, please like and subscribe. See you on the next one.